Hey guys, now that we already know how to find the kth term on a binomial expansion by using the formula t, k plus 1 is equal to n choose k, a to the power of n minus k, and b to the power of k, given that this is the expansion of a plus b to the power of n. Now that we know that, we can figure out we can solve a few exercises by using this formula here. So let's solve one exercise now related to this topic. And the exercise is to find the middle term of x squared plus 2 over x cubed to the power of 10. So the first thing is, what is the middle term of this guy? If we, for example, we expand a plus b to the second power, it's going to be equal to a squared plus 2ab plus b squared. If we, for example, let's use another even term here. Let's say we want to expand a plus b to the fourth power. We're going to have something like this. Actually, we're going to have exactly this, which is a to the fourth power plus 4a cubed b plus 6a squared b squared plus 4a b cubed plus b to the fourth power. So what is the middle term of this, guys? This is the middle term of this expansion. This is the second term. And this is the middle term of this expansion. This is the term number 1, 2, 3. This is the third term of this expansion. So we can figure out a generic way to represent the middle term. Let's say we have a plus b to the power of n. So the central term, or the middle term, is going to occur exactly on n over 2 plus 1. And when we look at what we have, which is the 10th power, the central term, or the middle term, is going to be exactly in the term whose number is 10 over 2 plus 1, which is equal to 6. It's the sixth term. So the sixth term is going to give us the middle term of this expansion here. Now we have to calculate the sixth term, and to calculate the sixth term, we're going to have to have k equal to 5. So when k is equal to 5, we're going to have the sixth term, which is t5 plus 1, which is the sixth term. It's going to be equal to, remembering that that n is equal to 10, so we have 10 choose 5 and not 6, 5. The a term is this guy. This is a, and this is b, so we're gonna have a to the power of 10 minus 5, given that a is equal to x squared, and we're gonna have b to the power of 5, given that b is this guy over here. So we're gonna have x squared to the power of 5 here, and 2 over x cubed to the power of 5 also. So we have 10 choose 5, which is 10 factorial, over 5 factorial, 10 minus 5 factorial, times x squared to the fifth power times 2 to the fifth power over x cubed to the fifth power also. So we have 10 factorial, which is 10 times 9 times 8 times 7 times 6 times 5 factorial over 5 factorial times 5 factorial also. We can cancel out these guys, times x to the power of 10, which is 2 times 5, times 2 to the power of 5 is equal to 32, 32. So we have 32 on the numerator, and we have x to the power of 15 over here. So we have 10 times 9 times 8 times 7 times 6. This guy is equal to, this whole term is equal to 30,240. And 5 factorial is equal to 120. And we have x to the 10th power over x to the 15th power. This quotient here is going to be equal to x to the 5th power on the denominator. So we have 30,240 times 32, which is this guy here, over 120 times 1 over x to the 5th power, x to the 5th power. So we have, as a final answer, we have 8,064 over x to the 5th power, and that is our final answer.